Hello, in this video we're going to do a fairly encompassing problem, bringing together consumer and production theory together. We're going to have a market with 40,000 consumers and 20,000 perfectly competitive firms. We're going to solve for the market equilibrium from the consumer's utility functions and the firm's production functions. There are 40,000 identical consumers, each with the same utility function given by the following. Utility equals X times Y. X is units of good X. Y is units of good Y. Each consumer has an income of $500 and the price of good Y is $1. There are also 20,000 identical firms, each with the same production function for good X given by the following, where K and L represents units of capital and units of labor. Capital is fixed in the short run at 4 units. The wage is $10 and the price of capital is $20. What is the equilibrium price and quantity of good X? We'll start with the consumer. We're going to derive the individual consumer's demand for good X. We're going to first create the consumer's budget constraint. The consumer has $500 of income. We're going to eventually solve for the price of good X. We don't know that yet. The price of good Y is 1, so I just got a 1 in front of the Y here. I'm going to take this budget constraint. I'm going to solve it for Y. Here's our utility function that we're given in the question. Where I have Y, I'm going to replace that with 500 minus the price of good X times units of good X, making that substitution. Now we can maximize utility. We're going to take the derivative of this utility function with respect to X. Before I do that, I'll just multiply this X throughout what's in parentheses. And now taking the utility function and taking the derivative of that with respect to X, setting that result to equal to 0, we are maximizing. We get the following result. And now I'm going to solve this result for X, and that is the individual consumer's demand for good X, 250 divided by the price of good X. Now we're going to derive the market demand for good X. There are 40,000 consumers, we're told. Each has the following demand that we just solved for. So what is the market demand for good X? It's just going to be 40,000 times the consumer's individual demand. So making a substitution in here for X. And now simplifying, this is the market demand for good X, 10 million divided by the price of good X. Now let's look at the firms. There are 20,000 identical firms, each with the same production function. Capital, as we mentioned, is fixed at 4 in the short run. What we want to do here is derive the firm's short run supply function. I'm going to plug this 4 for capital into the production function and simplify. So 5 times 2 will give us 10. And now I'm going to solve this for L, dividing through by 10. And now we need to square both sides. And we got an expression for L. Variable cost is the wage times units of labor. The wage is $10, and we solved an expression for L, which is just X squared divided by 100. So I'm going to substitute those two values into our variable cost equation on top. Doing that, we get X squared divided by 10. To get marginal cost, we can take the derivative of the variable cost equation with respect to X. Doing that, we're going to get 2X divided by 10, or just X divided by 5. So that is the marginal cost for the individual firm. In perfect competition, price equals marginal cost, so we can replace MC with P. And now we can solve for X, and that is the individual firm's supply function for good X. To get the market supply of good X, we know there are 20,000 firms. Each has an individual supply given by X equals 5 times the price of good X. So the market supply is just going to be 20,000 times lowercase x, where lowercase x is 5 times the price of good X. Making that substitution, the market supply for good X here is going to be 100,000 times the price of good X. Now, as for the equilibrium, that was our goal. Let's solve for the market equilibrium. We got the market demand and the market supply. We're going to set the quantity demanded equal to the quantity supplied. Setting those two equations equal to one another, I'm going to multiply through by the price of good X and divide through by 100,000. So we're going to have the price of good X squared over the following, which will just simplify to 100. 10 million divided by 100,000 is 100. And now taking the square root of both sides, get rid of this squared term. The square root of 100 is 10. To get the equilibrium quantity, take this $10 and plug it back to either into the demand or supply equation. Doing that, we'll see the equilibrium quantity is 1 million units. Each firm produces 50 units of good X. How do I know that? The individual firm supply is given by the following, and if the price of good X is 10, 5 times 10 means the individual firm produces 50 units. The variable cost from before we found was this, and we stated capital was fixed at 4, and the price of capital is 20. So as I said before, the individual firm is producing 50 units. To get the individual firm's profit, we're going to do the price times the number of units for the individual firm. So 10 times 50. And then we're going to subtract out the variable cost for the individual firm, which is going to be 50 squared divided by 10. And then subtract out fixed cost, the price of capital times units of the fixed capital. And we get a profit of $170 for the individual firm. And as for the individual consumer's demand is as follows. If the price is $10, the individual consumer will buy 25 units. Here is an individual consumer's budget constraint. We know now that the price of good X is 10 and the consumer is buying 25 units of good X. This means that the consumer will buy 250 units of good Y at $1 each. Okay, that's it.